Hello everyone, welcome to Gradeup. Let us continue the course on theory of machines and vibrations. In the last class we have learnt about the flywheels, the turning moment diagram and the flywheel and its concepts related to it.
Check out the link below for free GATE course that has more than 200 videos along with this video, followed by doubt sessions, previous paper and more than 250 quiz from Gradeup.
In this lecture, we will be doing some of the problems that have appeared in the GATE examinations recently concluded on the topic of flywheel. So let us begin. In the recent years, the number of questions asked from this topic after 2015 have not been there, but from 2013 till 2015, around 3-4 questions have been asked. So we are going to discuss that, and only these are the types of questions that can be asked from this topic. So as and when the question will come in the next coming years from this topic, the questions will be of similar type. So you can just have a look at these questions and get an idea that what kind of questions can be framed from this topic. Okay, so this is a question that is asked in 2013. A flywheel connected to a punching machine has to supply energy of 400 Newton meter while running at a mean angular speed of 20 radian per second. If the total fluctuation of speed is not to exceed plus minus 2%, the mass moment of inertia of the flywheel in kg meter square is. So in this case, what are the data that have been given? That this is the energy that has to be provided by the flywheel. In the last class, when we were talking about the application of the flywheel in the case of power presses, we saw that some energy was required, that there was some energy that was required for the press or for the punching operations, and then some energy that was provided by the motor, that energy that was provided by motor. So the other than this, whatever was required and whatever was not being able to provide by the motor, that energy was supplied, by the flywheel. That extra energy which is required and which could not be supplied by the motor, that has to be supplied by the flywheel. So in this case, that it is given that this much energy is to be supplied by the flywheel. So this becomes delta E, that is equal to 400 Newton meters, and it is given the mean angular speed. So this is omega is given to you as 20 radians per second, and this is given as the coefficient of fluctuation of speed CS, and in this case it is given as plus minus 2%. So plus minus 2%, I told you that whenever this plus minus is given, this numerical value has to be multiplied by 2. So this becomes 4%, or which is equal to 4 divided by 100, getting converted into fraction, this becomes 0.04. So simply equation, you know that delta E is equal to I omega square CS. Putting the values, delta E equal to 400, I you have to calculate omega 20 whole square into 0.04. 20 square is 400, so this gets cancelled from here. I is equal to 1 upon 0.04. This becomes 100 divided by 4, which is equal to 25. So the correct option in this case is I, that is the mass moment of inertia of the flywheel in kg meter square, is 25. Very simple question. Just you have to put this value, the notice on this value, that plus minus 2 has to be converted to 4, and the answer is 25.
Subscribe to our channel and press the bell icon to never miss any update from Gradeup.
Let us see the next question. 2014 set 2. The maximum fluctuation of kinetic energy in an engine has been calculated to be 2600 joule. So this is given as the maximum fluctuation of kinetic energy. That means it is delta E is equal to 2600 joule or Newton meters. Okay. First of all, it is maximum fluctuation, that's why it is delta E. And then I told you that the flywheel stores and delivers the energy which is in the form of kinetic energy. So this is given as the kinetic energy. Then next, Assuming that the engine runs at an average speed of 200 rpm, in this case omega is not given but the n or the rpm is given as 200 rpm, then the polar mass moment of inertia in kg meter square of the flywheel to keep the speed fluctuation within plus minus 0.5% of the average speed is, that is, this is given as a coefficient of fluctuation of speed, Cs equal to plus minus 0.5%, which is equal to 1%, or 1 divided by 100 equal to 0.01. But first of all, in this case you have to convert this n rpm into omega, that is omega equal to 2 pi n by 60. So you convert this 2 pi into 200 divided by 60, then you need to find out I, and you know the formula delta E equal to I omega square Cs. Delta E has been given to you 2600 equal to I, you need to find out the value. This is 20 in 200 into 2 pi upon 60 whole square into Cs is 0.01. So on calculating this, you will find that I is equal to 592.73 kg meter square. Very simple question again, based on the same basic equation, the fundamental equation of the flywheel, delta E equal to I omega square Cs. The only step, the extra step which you needed to do in this was just to convert this n into omega. That's it. Very simple question. The next one, 2014 set 4. The torque and angular speed data over one cycle or for a shaft carrying a flywheel are shown in the figures. The moment of inertia in kg meter square of the flywheel is. In this case also the I, the kg, the mass moment of inertia of the flywheel is asked, but in this case the data has not been provided to you in a numerical value, but the diagrams are being given. Okay, from this diagram you need to find out many datas. Okay, then how you will do it? See, first of all you can see that area of the, because first of all you need to find out the cycle is given, it is 2 pi, but first of all you need to find out the t mean. How? See, area of t theta diagram, the area of t theta diagram in this case will be this area plus this area. So this first area is 3000 into pi minus pi by 2 plus minus 1500 into 2 pi minus pi. So this is equal to 3000 into pi by 2, that is 1500 pi minus 1500 pi. So this is equal to 0 because this is above and this is below, so this is 0. Then you need to find, this is basically the work cycle. Then you need to find out T mean. T mean is equal to work cycle upon the total duration of the cycle, which is 2 pi in this case, so this is 0. Okay, so this you get as 0 first of all. Then you need to find out omega minimum. What is omega minimum? Omega minimum you can see from here, this is equal to 10 radian per second. Okay, then omega maximum equal to 20 radians per second. So from here you have to find out two things, one is Cs and other is omega, the mean omega and the coefficient of fluctuation of speed. So omega mean equal to maximum plus minimum by 2, that is 20 plus 10 by 2, which is equal to 15, and Cs equal to maximum minus minimum, that is 20 minus 10 upon the mean, that is 15, which is 10 by 15, which is equal to 0.67. So now you have got Cs, now you have got omega. Then one more thing you need to find out, that is delta E. What is delta E? In this case you see that this area is equal to this area, because this is also coming as 1500 in positive and this is coming as 1500 in negative. So this is also 1500 pi and this is also 1500 pi. Any area above the T mean line or T mean below T mean line is the fluctuation, and if that area is maximum, that is the maximum fluctuation. So in this case, the area above the T mean line and below the T mean line are same, so any one can be taken as delta E. That means in this case delta E is equal to 1500 pi. Then the basic equation, delta E equal to I omega square CS. So delta E is 1500 pi equal to I, need to calculate, omega is 15 is square into CS. What is CS? 0.67. On calculating this, you will get this as 31.26 kg meter square. So 3 questions we have seen. In all the 3 questions, only I, that is the mass moment of inertia of the flywheel, is being asked. But in this question, the one variation was there, that the data was not given you numerically, but some of the figures have been given. But still it's a very easy question. Just you need to find out the delta E, the mean omega, and the coefficient of fluctuation of speed from this diagram. So this is again very same question, similar question. Answer is 31.26 kg meter square. Okay. The next question, 2015, set 3. The torque in Newton meter exerted on the crankshaft of a 2-stroke engine. See, this is 2-stroke engine. First of all, this is given as 2-stroke engine. So the cycle has to be calculated from 0 to 2 pi. You can write it here if you want. The cycle is from 0 to 2 pi because it's a 2-stroke. 0 to 2 pi because it's a 2-stroke cycle. Then the T has been given, the turning moment has been given as 10,000 plus 1000 sine 2 theta minus 1200 cos 2 theta, where theta is the crank angle as measured from inner dead center position. Assuming the resisting torque to be constant, the power in kilowatt developed by the engine at 100 rpm is. Very simple question. You just need to know that power is equal to T mean into omega. Okay, omega can be directly calculated from here because this is N has been given to you equal to 100 rpm. You just need to find out the T mean, and for finding the T mean you need to find out the W cycle, that is from 0 to 2 pi into T d theta. Okay, so in this case if you will do this as 0 to 2 pi 10,000 plus 100,000 sine 2 theta minus 1200 cos 2 theta whole integration like this. So you will get this as 10,000 pi Newton meters. Okay, this is W cycle. So T mean equal to W cycle. T mean is equal to, so you will get E, you will get this as 2 pi. Sorry, this is 2 pi. You will get this as 10,000 into 2 pi. So the T mean is equal to W cycle upon 2 pi. So in this case this will come as 10,000 into 2 pi divided by 2 pi. So you will get this as 10,000 Newton meter. So this is a constant value, and also it has said that the load or the resisting torque to be constant. So we have got this as constant. This is T mean. Then it is very simple. Power is equal to T mean into omega, and the omega is equal to 2 pi into N by 60, which is equal to 2 pi into 100 divided by 60 because N has been given to you as 100. Okay, so T mean is equal to 10,000 into 2 pi into 100 divided by 60. If you will solve this, you will get this as 104,719.755 plus. But just remember that this will be in watt and the answer has been asked in kilowatt. So you need to divide this value by 1000, and on dividing this value by 1000 you will get the answer as 104.719 kilowatt. Again, very simple question. Power has been asked and you have to calculate the T mean in this case and then the omega from the N value. So these are some of the basic questions that have been asked, and all the questions are just directly the application of the parts that we have been dealing with during the lectures. Nothing out of that has been asked, and all these kind of questions has been asked in the previous examinations. And if the questions come from this topic in the next coming years, in this year or the next year, the same kind of questions will only be coming. You just need to understand the basic variations and then you can easily solve the problems. Okay, so this is all about the questions on the flywheel. In the next class we will start a new topic on the governor and the related concepts to it. Till then you have to practice a lot many questions from the books, from the test series, the mocks and the quizzes. If you have any queries, you can write to us on the Gradeup app on the website. See you in the next class. Thank you.